Welcome back to our second lesson. I'm going to look at another part of the ES2 now, one which is the filter here. Now, the filter it can be an incredibly easy thing to use, and the more you look at it, it can be an incredibly difficult thing to use as well. It's often common to know how something can make something sound, but you don't really understand what it's doing. So I'm going to go through each point here and make sure we understand what this filter is about. And there are a couple of extra features that are special about the ES2's filter as well, that you'll probably find interesting and useful for your projects. So let's start with some of the terminology, which you should understand by now. And first of all, what I'm going to do is I'm going to change this blend bit at the top. Now, it's important to understand that this filter comes in two parts. This is the first part of the filter, and this is the second. Now, what that actually means is when this is in series, which is this, basically part 1, then part 2, what happens is our sound from the oscillator will go through part 1 of the filter first, and then it will go into part 2. When it's in parallel, basically what will happen is the sound will come from the oscillators and it will run through everything at once. It won't run through the both parts separately. It looks at the filter as a whole, and all the settings happen at once. And I'll show you how that sounds a little later when we've changed some of the settings. I'm going to change it back to series and go back to this blend option. Now, this blend option is very similar to the blend in the oscillator. It basically sets which part of the filter we're using. At the moment, it's set all the way to 2, so even though 1 has settings on it, it's going to ignore it entirely because we're only using the second half of the filter. If I change that to, in fact, let's hear it. Doesn't that sound lovely? That's how the right-hand side of the filter sounds. Now, if we change that to 1, sorry, the settings are the same. Let me change that slightly. So that's 2, and this is 1. And we can hear the difference because I've changed the cutoff point. So it sounds completely different. Now, if you want to hear both, setting that in the middle will give us an equal mix of the two. Now, what we want to concentrate on, and for this I'm just going to concentrate on the first half of the filter. The first thing we need to decide is what kind of filter this is going to become. Is it going to be low pass, high pass, band pass? I'm going to concentrate on those three as they're the most common. Now, what this means is it going to cut high frequencies from the sound? Is it going to cut low frequencies from the sound? Or is it going to do both? Now, you may have noticed that I've got an EQ unit up to my right, to try and show you how this actually works. You guys should be very familiar with the EQ unit by now. So the low pass filter, as the name suggests, lets low frequencies pass through the filter, and it removes all those higher frequencies from the sound. So just to give you an idea of how that would look, basically if we roll off that high end in our EQ, it's letting all the low frequencies through and it's cutting the high ones. So a low pass filter looks like that on an EQ unit, and I'll let you know how that sounds in a second. A high pass, if I changed it to here, does the opposite. It lets the high frequencies pass and cuts the low ones. So all the low ones are being filtered out and all the high ones are being allowed through. Now, band pass allows the middle frequencies through. So basically what it does is a bit of both. It basically does that. It cuts the highs and cuts the lows and leaves you a middle point. Now, in order to understand this properly, we need to understand this part, and this is what we call the cutoff. Now, the cutoff decides at what frequency it will start to roll the sound off. Now, what I mean by that is the following. Let me just bypass this filter. So, if I play a nice high sound, that's quite harsh, and I'm going to bring that cutoff frequency down, and you're going to be able to hear what it's doing to the sound. essentially what that is doing is this. Now I'm going to recreate that using an EQ unit, showing you how it's rolling off. Basically, that cutoff is moving this, just like that. And you'll hear a very, very similar sound happening to the one you just heard when I used the filter on the synthesizer itself. Now we start with it open, and it sounds exactly the same as it did before. And as I start to move that point and roll off the frequencies, you'll hear it change. So what the cutoff is actually doing is it's controlling essentially one of these. It's controlling the point at which the filter is cutting off sound. It's controlling the frequency point. So I'm going to bypass that again. I'm just going to bring this down a little bit. Now this brings us on to resonance. And what resonance does is it boosts frequencies around that cutoff point. So if I set the cutoff point somewhere like, let's turn the analyzer on so you can see what it's doing. I'm going to set the cutoff point about 3/4, so it's about there on my EQ unit. So when I press the key down, you can see where my sounds are, my frequencies are just there. Now, if I turn the resonance off, what you'll see is you'll see a spike happening around the cutoff point, because what I'm doing is I'm boosting the frequencies around that part. So I'm going to play a note to begin with so you can see it on the analyzer. And we can see all the frequencies that make up that particular wave. Now what I'm going to do is I'm going to turn up the resonance and you'll see a boost in frequency. Now that's telling me that my cutoff point is set to just above 2K. It's set to about here. Now if I move the cutoff point with the resonance on, you will see that little spike move up and down on my EQ unit. So and as you can see, that the resonance was boosting the frequencies around wherever I set the cutoff to. It can hurt your ears. That hurt my ears a little bit, certainly. But if you're looking for a really detailed synth sound, something that sounds nice and bright or has a lot of distinction to it, then the resonance is something certainly worth having a go at. What else can we talk about on this? Let me take a look at my notes. I was going to have a look at the drive. Let's see if you can see what it does before I start. I'm going to turn the resonance down just because it's killing my ears a little bit. That's a bit better. Let's turn up the drive and see if we can see what it's doing. I hope you can see what that's doing. It's boosting a lot of the higher frequencies. In fact, it's boosting everything as a whole. It almost adds a little bit of distortion to the sound, and it adds essentially more drive to the sound. It makes it more powerful, and the crunchier your synth is to begin with, the more crunchy and static it's going to sound afterwards. Now, the only other thing on here that needs to be explained is the FM here. Now, FM is a very interesting option on this filter, and as you can see, I've had to move my blend across in order to hear that. Now, FM is frequency modulation, and it's directly linked to oscillator 1. It's not linked to 2 or 3, it's only linked to 1. Now what that does is it boosts and modulates frequencies around the tuning of oscillator 1. So at the moment this is set to 0, so whatever I play on my keyboard it will sound like that. So if I play my sound again, what you'll see when I boost the FM, you'll hear hopefully an A note being boosted. You should hear that being modulated in the background. It'll sound like this. In the background, you should hear a sine tone ringing out, almost like a drone. In fact, you might hear it better if I change this wave type. In fact, let's change everything else to a sine wave and have this one as the buzzing tone, so it's a lot easier to hear. I'm going to turn down FM again, and this should be a lot more obvious. So yeah, it's boosting that particular sound around the tuning of oscillator 1. Now if I change the tuning live, you'll also be able to hear the FM, the frequency modulation, changing live as well. And it sounds like this. Just like that. Isn't that a pleasant sound? That's basically the filter, and I'm hoping what we can do now is if I just change the cutoff slightly, I'm hoping that I've got settings that will lend itself to series and parallel settings, so you can hear the difference. So at the moment this is series. It runs through the first filter first, and then it runs through the second one second, surprisingly enough, and it sounds like this. Now if I change that to parallel, we should get a different sound. You can probably hear the attack is much louder the second time. However, if we run it through series, it'll have a much slower attack because of the settings that I've got and the way that they're different compared to. And that's because the filter is different. So remember, series means it runs through the first part first, and then it runs through the second. And parallel means it treats it as one big filter, and it does everything at the same time. As before, if you can answer my questions for me, make sure you're signed in when you do that. And next time, we're going to concentrate on 3 things at once. We're going to look at the patch bay in the center, we're going to look at the low frequency oscillators, and the ADSR, basically because they're all linked.